In section 3 of chapter 1, we're going to be testing the solutions of linear inequalities. So we are moving briefly away from linear equations, which have equal signs in them, into linear inequalities, which have those greater than, less than symbols in it. But first, I got a question for y'all. What does it mean to be a solution to an equation? What does that mean? Yeah?
What makes the equation true?
What makes the equation true?
And the solution, like evaluated and it's true.
Okay. Yeah?
Like for like an equation of a line,
Sure.
it's like the point that you plug in is on the line.
There we go. The point is on the line. Here's another example. If I gave you the equation 3x minus 8 equals 10, that x, because it's a single variable, that x has one solution. It actually has a value. We just don't know what it is yet. It is equal to a number. And all that algebra that you learned back in algebra 1, where you add 8 to both sides to eliminate the 8s, leaving you with 3x equals 18, and then you divide both sides by 3. This entire process was just so we could discover what x is actually equal to. So in this problem, x is 6. The solution was 6. But solutions for problems when there are multiple variables is different. If you have an equation like 2x plus 5y equals 9, now we have two variables, x and y. A solution looks different. A solution would be a coordinate like 2, 1. And the way that we would prove that that coordinate is a solution, aka it's on the line if you graphed it, is you take the x value of 2 and substitute into the equation. You take the y value of 1 and substitute into the equation, and something unique happens. You'll get 2 times 2 plus 5 times 1 equals 9. 2 times 2 is 4. 5 times 1 is 5. And 5 plus 4 plus 5 is 9. We are left with a true statement. Therefore, that coordinate was a solution to this equation. The main difference between these two is problems with a single variable will have a single solution. Equations that have multiple variables will technically have an infinite number of solutions. We just found one of them because a line is made up of an infinite number of coordinates. So that's what it means to be a solution to an equation. What does it mean to be a solution to an inequality? Yeah?
If you plug it in, if the inequality is true, so it's like in the range of the inequality.
So what would make it different from an equation in terms of the number of solutions?
Just like it has infinite amount of solutions.
Are there any inequalities that have single solutions?
Yes.
Give me an example.
X is. Oh, actually, I don't think so.
Are there any inequalities that have single solutions?
No, that's an inequality, so it can't be equal to anything.
But if it's equal, then
It's not an inequality.
it's not an inequality.
So.
So are there inequalities that have single solutions?
No.
That's what separates an inequality from an equation, an equal sign. Equal signs can have a single solution or a multitude of solutions. Inequalities, by definition, can only have an infinite number of solutions. So what I mean by that is, if you have something like 8 minus 5x is greater than or equal to negative 2, and we solve this by subtracting 8 from both sides. I also have a little review of inequality mathematics written in here. That's negative 10. We divide both sides by negative 5, and this is the thing that most students forget because they haven't dealt with inequalities in a while. If you ever multiply or divide both sides of an inequality by a negative, you got to flip the direction of the inequality. This is the answer, but there's an infinite number of numbers that are smaller than 2. So that's what it means to be a solution to an inequality. You're going to have a bunch of answers. here's what we are doing today. I am going to give you an inequality. I am going to give you a coordinate. Your job is simple. Tell me if it's a solution or not. The way we determine that is you take the coordinate, plug it into the inequality. If it produces a true statement, it's in the solution set. If it produces a false statement, it is not in the solution set. We're just figuring out if these are answers. So for problem number 1, I have 2 comma 5. That means it's going to be 2 times my x value, which is 2, minus 3 times my y value, which is 5, is less than 7. I'm just going to simplify this. 2 times 2 is 4. Negative 3 times 5 is 15. 4 minus 15 is negative 11. I ask myself, is negative 11 smaller than 7? Yes. It is important that you say yes. That's your answer. This is how you get to your answer. It is not your answer. You need to tell me yes or no. Because negative 11 is in fact smaller than 7. Then do the same thing with all of these problems. So it's going to be 2 times the x value, which is 4, minus 3 times the y value, which is negative 1, is less than 7. 2 times 4 is 8. Negative 3 times negative 1 is positive 3. 8 plus 3 is 11. 11 is not smaller than 7. So the answer to this is no. That means when I graph this inequality, this coordinate will be part of the answers. This coordinate will not. And then my last one, just because I feel like doing all 3 problems, since I wrote them all up here, would be 2 times my x value, which is 0, minus 3 times my y value, which is 3, is less than 7. 2 times 0 is 0. Oops, wrong color. Minus 9 is less than 7. Negative 9 less than 7. That is true. So my answer is yes.